to a chord bisects that chord. Oh, maybe we should start with some words for parts of circles. Let's make sure you all know the right words, shall we? That might actually be useful. Let me do that. Tangent. I think you know radius and diameter, right?
Yes.
Some words you will need to know. A secant is a line that goes through a circle. If the secant just touches the circle, it's a tangent. If we're only talking about the bit inside the circle, then we're talking about a chord. This is also a chord. The piece of the circle the chord cuts off is called a segment. This is also a segment. The other side of that chord is also a segment. And I think you already know radius and diameter. You should already know radius and diameter. Diameter. That one was I was writing sideways. You will need to know that. So when I'm talking about a chord, I'm talking about a line, a line segment inside a circle. Technically, a diameter is a chord. It's a chord that goes through the centre. Technically, a tangent is a secant. It's a secant that touches at only one place instead of two, depending on how you define it. So I want to prove that a radius perpendicular to a chord bisects the chord. A radius perpendicular to a chord bisects the chord. A, B, we'll call this point P, where we have a perpendicular intersection. Okay. We okay so far? Your diagrams need to pass my rule of thumb. If I can cover your whole diagram with my thumb, it's too small. Because of the things we're going to have to draw on these diagrams, you'll get away with it for this one, Claire, but for the ones that are coming, it's bigger. You want to be able to draw on them, lines all over them. I'm going to want to label some of the angles inside that circle. It's going to get tricky if it's too small. I'm going to add 2 extra lines. What can you tell me about OA and OB? Year 11 student. What can you tell me about OA and OB?
You know this. Equal.
They're equal because?
They go to the centre.
Because they're both radii. Yes. Okay? OA, length of, is the same as OB as both radii. One radius, two radii. That was complicated. All right. And I specifically said I want this angle to be a right angle. So, now look carefully. These two triangles have a right angle in them. The hypotenuse is the same length, and they share another side. That means those two triangles are
Congruent.
Come on, everyone else. That means those two triangles are congruent. Good. All right. So carefully the way we label. Let's go OA. Let's go triangle OAP is congruent to triangle OBP as right angle hypotenuse. If you like, other than that, we might go like this: right angle hypotenuse and another side. They are congruent. What does that mean? That means AP length of must equal BP. And I've proven that a radius drawn perpendicular to the chord must bisect that chord.
So does bisect just mean go through it?
No, bisect means divides equally in half. Did I need to define that word as well, did I?
Maybe.
Bisect divides in half exactly. Or, for example, from the syllabus to use it, suppose I have this triangle. No, that was triangle. Circle. Centre. What am I drawing? Okay. Oh, I didn't even. They'd actually drawn the right angle instead. That was a funny looking straight line, wasn't it? Right angle, 25, 18. And you have to calculate x. This was supposed to meet at the edge of the circle. That's my drawing for you. Now you see why your diagram has to be a little bit bigger? You can fit all these numbers and angles and things in it. Well, you ready to go on? You've drawn the diagram? How do I work out what this is? Well, it's perpendicular to a chord, so this must equal that. Right? They're the same length. This is a radius, so it must also be 25. So how long is this bit here? It has to be how big, April? 7 is correct. This bit must be 7. Now I have a right angle triangle. How do I work out the third side? Check me. Don't ever believe me. In this case, I know I'm wrong. I know my Pythagorean triads.